Hello everyone, welcome back to the ITversity YouTube channel, and this is Raghu, and today we have a brand new full course on Apache Spark and getting started with programming in Apache Spark. Now if you look at Apache Spark and if you want to work with Apache Spark, there are three primary data structures, one called RDDs, then DataFrames and Spark SQL, and then there are APIs on top of all three data structures as well. So since this is the first video in getting started with Apache Spark, we will be starting with the core or the foundation API, and that is called RDD. So in this course, we will start by introducing what is Apache Spark, what are its features, and then we'll slowly get into programming in Spark using RDDs. And if you want to write your code and if you want to experiment with Spark, then one of the prerequisites is that you need a hands-on platform where you can experiment with this. And if you check out our playlist and if you look at the first video in this playlist, then you can see there is a video which talks about getting started with DataBricks Community Edition. Now, DataBricks Community Edition will allow you to spin up Spark clusters in the cloud absolutely free, and you will be able to run your code. So in case if you do not have an account with DataBricks Community Edition, then please create an account and then watch the video so that you can follow along with whatever we are explaining here, right? So once you have a DataBricks Community Edition, then you can start right with Spark, writing your first lines of code using RDD. And if you're somebody who has not subscribed to our ITversity channel, then please consider subscribing to our channel. Also like this video, share it with your friends who might benefit from this video. And what are your thoughts about this particular video series? Please let us know in the comments. And also, what are the other areas or tech topics that you want us to come up with content? Let us know in the comments section so that we can come up with brand new content for you, right? And also watch this space for more content, because this is the first video in an elaborated series where we will be discussing programming in Spark using DataFrames, Spark SQL, case studies, and much more, right? So this is the first full video in that series. So hit on the bell button so that you will be notified when we upload more videos and you can watch them. And let's now get started with an introduction to Spark and getting started with programming in Spark using RDD. Let's begin.
Before getting into actual details with respect to Spark data structures and APIs, first let us understand what is Spark. You can go to official page of Spark, which is nothing but spark.apache.org. You can see the definition of Spark. It says Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on single node machines or clusters. The fundamental aspect with respect to Spark is nothing but distributed computing. I'll get into the details very soon. But first, let us understand what is multi-language engine. When it comes to Spark, Spark provides APIs using programming languages such as Java, Scala, Python, R, and also SQL. Hence, it is known as multi-language engine. Also, it says it is used for executing data engineering, data science, machine learning. These are the use cases which can be deployed on Spark or using Spark. Also, when it comes to Spark, it runs either on single machine or multiple nodes. Predominantly, Spark is run on multiple nodes. For learning purposes and development purposes, we might end up using a single node, but typically we use Spark on multiple nodes. It is because Spark is distributed computing framework, or Spark have distributed computing engine. Here you need to understand the term distributed computing. First, let me explain in simpler terms what distributed computing means. Then I'll actually get into the details using Spark. Now, let's say you have a big library. Let's assume there are hundreds and thousands of books in the library, and you want to get all the books with the title Atomic Habits. The book might be scattered across the library, and you want to get all the books at one place so that they are placed appropriately in a specific location within the library. Now, with a single person, he has to go through entire library, make sure he pick atomic habits wherever it is available, then he have to consolidate and take it further. Depending upon the size of the library, it takes its own sweet time if only single person have to search the entire library. Let us assume there are 60,000 books in the library. If only one person have to check, he has to go through all 60,000 books and confirm wherever atomic habits is. Then he have to get all atomic habits titles into one area. This will be a bit tedious task, and also it takes time depending upon the size of the library. If the size of the library increases, his effort also will increase. By the time he complete, it will be very long time. Let us also assume that the library have 10 rooms. If we assign the task to 10 people where each person go into individual room and then search for books, then we'll be able to get 10x performance. If for single person to count or to get all the atomic habits takes 10 hours, with 10 people, most likely the task will be done in 1 hour. In the similar manner, if the task is assigned to 5 people, then the task will be completed in 2 hours. Depending upon the amount of resources, we'll be able to complete the task proportionately. That being said, now if you attempt to compare this with the computing, the first scenario where single person searching the entire library is like using a single computer to process data. The second scenario where multiple people searching the library in a distributed fashion is like using multiple computers to take care of processing the data in a distributed fashion. However, the software should be smart enough to understand all the computers. It has to coordinate with all the computers and complete the task. That's where Spark comes into play. Spark is capable of understanding all the computers assigned to its framework. Whatever workloads we give to Spark, it will attempt to use all the computers and get the results faster. That's why Spark is known as distributed computing engine. On top of it, Spark also uses memory more efficiently compared to traditional distributed computing tools such as Hadoop. That's why Spark gained a lot of popularity at the cost of Hadoop. That being said, when it comes to key features with respect to Spark, on top of distributed computing, it can take care of processing the data in batch or streaming fashion. We can also take care of SQL analytics using Spark. Also, we should be able to build data science applications and machine learning applications at scale. These are some of the important aspects with respect to Spark. Yeah, we have understood what Spark is all about. Now it is time for us to get into details related to Spark data structures, APIs, and also how to develop simple applications such as word count. While exploring how to develop applications such as word count, we'll also touch base quite a few other concepts which are relevant to Spark. Now let's get into exploring datasets provided by DataBricks. DataBricks provide quite a few free datasets. We should be able to use those datasets to understand all key concepts with respect to Spark, including data structures as well as APIs. That being said, we'll be using DataBricks Notebook to take it further. The DataBricks Notebook will be created in Community Edition. If you haven't created an account in Community Edition, you need to first create the account. It is very straightforward. You should be able to quickly create the account and take it forward. However, you need to spend some time in understanding the interface. If you haven't spent time in understanding the interface, I would highly recommend you to watch the video that is provided in the description to not only sign up to DataBricks Community Edition, but also understand the interface a little bit better. Once that is done, then you can come back here and then you can take it further. You just have to log in and then click on Create Notebook to get started. Once the notebook is created, you need to make sure the notebook is attached to running cluster. You can see it is attached to running cluster. Hence, we should be able to use this. Before taking it further, let me rename this notebook. I am saying word count PySpark. The reason why I have named after PySpark is because first I'll be going through concepts related to data structures and also APIs using Python-based approach. PySpark is nothing but Python plus Spark. The APIs which are provided using Python as programming language is termed as PySpark by Spark community itself. That being said, here we should be able to use %fs_ls to list the files. The location is nothing but dbfs:// then databricks-datasets. Now you can run this. Let me click on allow. It will take a moment to run. You should be able to see all the datasets in this location here. There will be quite a few subfolders in this. Also, there will be a file by name readme.md. We'll be using readme.md to actually take care of word count. Let's wait until this command is run, then we will take it forward. Now the command is run successfully. You can see here. You can see the names here. Some of the names end with /. If you have / at the end, that means they are folders. If you don't have / at the end, that means they are files. So this is folder, this is also folder, this is also folder. However, this is a file and this is a file. This is readme.md and this is spark_readme.md. When it comes to readme.md, it is only of size 976 bytes, whereas spark_readme.md is of size 3369 bytes or 3.3 KB. As this is bigger file, I'll be using this for word count. This is how you should be able to review the datasets and take it forward. We'll be using other datasets as well when we get into other topics such as developing SQL queries using DataFrames and all. For now, we'll be using spark_readme.md to explore word count. As we have reviewed the datasets, now let's take it forward. We'll understand how to read the content from this file into RDD. I will also explain what RDD means, and then we'll understand how to process the data in RDD as well. As we have reviewed the datasets provided by DataBricks, before getting into Spark RDDs, we need to revise the concept of data structures or collections. When it comes to Python, the data structures are known as collections. The four different types of collections are nothing but these. The first one is nothing but list. Then we have tuple, dict, and set. These are the four different types of collections we have in Python. With respect to RDDs, list and tuple are important, but in general, we should be quite comfortable with Dict also. List, tuple, and Dict are widely used when it comes to data engineering. Set is also important, but it is not as important as others. Now, as we are speaking about RDDs at this time, I'll just focus on list and tuple. When it comes to list, the syntax is like this. You can define a variable, then equal to, then you have to use square brackets. Within square brackets, you should be able to specify the elements you want to create list. Let's say I wanted to create a list of integers where the numbers are nothing but 1, 4, then 2, then 8, then 3. In this case, I have created a list of integers. The number of elements in this list is nothing but 5. Now, let me run this. You can see the list is created. If I say type of L, you can see it have returned list as type. You should be able to use first class functions like len to get number of elements in any iterable, not just list. All collections are iterables, whether it is list or tuple or dict or set. With respect to getting number of elements in any of the iterable or collection, we should be able to use this first class function called as len. You can see we got 5. Then when it comes to tuple, the syntax is like this. You can say t equal to, then you have to use circle brackets for tuple. Then you can specify the numbers like this. This is a tuple with 5 elements. The main difference between list and tuple is nothing but tuple is immutable, whereas list is mutable. Mutable means we can actually update the list, we can delete elements from the list, we can insert another element somewhere in the middle when it comes to the list. When it comes to tuple, it is immutable, which means you will not be able to delete any element from the tuple. You cannot insert any element somewhere in the middle of the tuple. When it comes to accessing the elements in a list or tuple, we should be able to use this approach. First, let me run this to create tuple by name t. Let's also say type of t to review the type with respect to t. It is of type tuple. Now, to access elements in a list or tuple, we should be able to use this approach. We can say L or t, then square brackets, then 0 to get the first element. The index with respect to list or tuple starts with 0. Let's also try with t of 0. You can see it have returned 1 because the first element in both list and tuple is 1. In case if you want to get first 3 elements, you have to say L, then colon 3, it will give us first 3 elements in the list. You can see it have returned 142. When it comes to the original list, we have 14283. As we have understood how to get first 3 elements, let's also review how to get last 3 elements. Let's take tuple, which is nothing but t. To get last 3 elements, the first argument should be -3, then colon. It means from the end, get 3 elements. You can run this and you can see the outcome. It have returned 453. The original tuple contains 1, 2, 4, 5, 3. The last 3 elements are nothing but 4, 5, 3. The results are as per the expectations. So whether it is list or tuple, you should be able to use the square brackets to get the elements from list or tuple. That being said, there are quite a few operations with respect to lists and tuples. In case if you are completely new to this, you should learn Python collections a little bit in depth first before you get on to Spark. We have these covered as part of our other modules. Just focus on those and then take it forward. One of the key aspects which you need to keep in mind is how we typically represent the records in the table if you want to use these data structures. Typically, we use list of tuples. It will be something like this. Let me say LT list of tuples equal to, then in square brackets, you can have as many records as you want. Each record can be represented as a tuple like this. And then we'll be having the elements related to each record in these tuples. For example, let's say you have users data. You have user ID, user first name, and user last name, and you want to represent as a list of tuples. Then each of the tuple will have user ID, then first name, then last name. It will be something like this. The ID is 1, then the first name is John, the last name is Doe, then 2, this is related to second element, user ID is 2, again this is second tuple in the list. Then the first name is probably Srinu, then last name is Moti, then user ID 3 for third tuple, first name can be Anu, then last name can be some XYZ. This is how you should be able to create a list of tuples. Now let me run this. The list of tuples by name LT is created. To get the first element, I should be able to say LT of 0. The first element is of type tuple. You can see the tuple here. Now to get the first name from this tuple, I should be able to say LT of 0, then of 1. In this case, the of 1 should be outside this square brackets. So after this, I have to specify square brackets, then I have to specify 1. This is how you should be able to access John in this list of tuples. LT, then 0, which is nothing but this one, then 1, which is nothing but this one. Let's run this and you can see the outcome. Now, if you want to get the first name of the third element in this list, then you have to use this approach, LT of 2 or even -1 to get the last element. In this case, I am using 2 to get the third element. Then I should be able to say of 1 or square brackets 1 to get the first name from the third element. This is how you should be able to access whatever you are looking for. On top of just accessing, we should be able to perform quite a few advanced operations using functions that are available on top of functions. For example, let's say here I wanted to sort the data by first name, which means the data should be sorted by these values, John, Srinu, and Anu. So the first one should be Anu, followed by John, then followed by Srinu. The way you typically sort is like this. You have to use sorted function. Then you have to pass the list, which is nothing but LT. Then you have to say key equal to, then lambda. Then you have to specify the key based on which data is supposed to be sorted. In this case, let me say I for item, then I of 1, which means second element in each of the items. Now let's run this and see whether data will be sorted as per the expectations or not. You can see data is sorted based on first name in these elements. This is how you should be able to not only access data in Python collections, but also perform operations such as sorting. Not only sorting and accessing the elements, you should be able to perform whatever operations you want. That being said, let me also introduce you to a very important function called as parallelize. It comes very handy for learning purposes. At any point in time, if you wanted to create RDD, you don't need to read data from the files. You can just create RDD using parallelize function. As I have mentioned to you earlier, we have something called as SC in the notebooks in DataBricks. It is of type Spark context. It exposes a function called as parallelize. Let me say help, then let me say sc.parallelize. Now let me run this. Let's go to the details here. When it comes to the definition, it says distribute a local Python collection to form an RDD. Using range is recommended if the input represents a range for performance. You can ignore the second part of it, focus on the first part. It is saying distribute a local Python collection to form an RDD. So in this case, if you wanted to create RDD out of this LT, we should be able to use this function. We can say sc, then dot, then parallelize, then we should be able to say LT. Now RDD is created. As RDD is created, if you wanted to preview the data, you can actually use take of 10. You can see the outcome. It have returned the original list of tuples. However, when it comes to sc.parallelize, it is RDD, not collection. You can see the type of sc.parallelize here. It is nothing but parallel collection RDD. RDD is the keyword. RDD stands for resilient distributed dataset. Now we should be able to go to details with respect to overview of RDDs, and then we'll take it forward. Also, why we use parallelize, I'll give an example, then I'll wrap it up. Let's say I wanted to explore an API called as reduce, which is available on top of RDDs. Instead of reading data from the files and then converting into list of integers to use reduce to get sum, I should be able to create a list like this. Already we have a list by name L. It contains these 5 elements. Let's make sure this is run once again. Then I should be able to use sc.parallelize like this. sc.parallelize, then L. RDD is created. Then I should be able to use reduce function. When it comes to reduce, we perform operations such as add. Let me import add here. We can say from operator import add, then sc.parallelize of l.reduce, then add. Now let's run this. You can see the outcome. It have returned 18. Let's review the data in L. We have these 5 values. If you add these, it will result in 18. You can also use sum on L. Sum is first class function in Python. You can pass iterable to it. As long as the iterable contain only integers, we should be able to get the sum. Let's run this, and sum of these 5 elements is nothing but 18. Here also we got 18. This is how parallelize can come handy. I just wanted to show an example here. When it comes to functions like reduce, don't worry at this time. We'll be talking about those in detail at a later point in time. Before getting into Spark RDDs, I have covered quick revision of Python collections. Have you enjoyed it? If yes, you should be able to move forward and explore Spark RDDs and other concepts with respect to Spark as well as data engineering. But if you have any discomfort understanding the Python collections, that means you haven't prepared enough with respect to Python. At ITversity, we have quite a few videos around Python. There are a couple of them tailored for data engineering. The first one is nothing but Python for beginners. You can actually look at the link here. Using this link, you should be able to go to Python for beginners and learn Python at beginner level. We have covered basics of programming using Python, all key aspects such as variables, operations, control flows, syntax, even Python collections are extensively covered in this. Towards the end, even there is a project. On YouTube, you will get all free content. However, if you wanted to take the exercises and also get your solutions reviewed by our experts, then you can actually sign up for our course on our LMS. The details will be provided. You can reach out to us by sending an email to support@itversity.com. That being said, on top of this Python for beginners, we have another course. Again, look at the link here. If you click on this, it will take you to another video. It is about Python for data engineers. It's a full course tailored for data engineers. It covers revision of Python. It covers collections quite extensively. It also covers Lambda functions. On top of this, it also covers pandas, because when it comes to lightweight workloads, as data engineers, we use pandas also quite a lot. Hence, you should be familiar about pandas as well. On top of this, you will also learn how to interact with the databases using Python. There are a couple of projects also. So here also, you will get the complete course content in the form of video for free in YouTube. However, if you want to get our support while learning, feel free to sign up for our course. You can send an email to support@itversity.com. We'll direct you towards taking our course. Keep in mind, Python is one of the required skills when it comes to data engineering. If you don't have Python as a skill, forget about growing. You might not be able to sustain in that role for very long. You have to learn Python to be an effective data engineer. Whenever you get a chance, don't forget to like, comment, as well as share with your friends. Also, don't forget to subscribe and hit on bell icon so that you are notified whenever we publish good quality content on our channel. Also, don't forget to review the description. There are quite a few links to additional resources which can come handy from the perspective of data engineering. That being said, happy learning. Let's get into overview of Spark RDDs, then we'll take it further. When it comes to Spark, there are three types of data structures. First, let us list those three types of data structures, then we'll go through each of these types of data structures one at a time. The three types of data structures are nothing but RDDs, then datasets, then DataFrames. When it comes to RDD, the full form is nothing but resilient distributed dataset. Here the keywords are resilient and distributed. You need to understand these terms. When it comes to Spark, RDDs are the fundamental data structures. At the lower level, everything will be converted to RDD. Even dataset or a data frame will be converted to RDD. Even though RDDs are used internally by Spark all the time, we might not develop applications using RDDs in the modern world. We typically use high-level APIs which are provided by DataFrames. However, when it comes to these DataFrames, when the data is processed based on the logic that is developed, the DataFrames will be converted into RDDs at low level, and then RDDs will be processed by Spark engine. The keyword with respect to RDD is nothing but resilient. Another keyword is nothing but distributed. You need to make sure you understand the data structures in Spark are resilient as well as distributed. It is termed as distributed because there will be multiple executors which will be processing the data. Hence, it is distributed. It is resilient because it is reliable. Spark have inbuilt fault tolerance. In case if one of the executors fail, the duty of processing the data which is supposed to be processed by that executor will be transitioned to some other surviving executor. Even the data will be transferred to that executor. Without knowledge of the failure to the individual who submitted the application, the data will be processed without any gaps, even though there are failures with respect to executors. As Spark have inbuilt fault tolerance features, when it comes to RDDs, they are also resilient. So resilient distributed data set means it's a reliable distributed collection or data structure. It is very, very important for you to understand this. Also, once again, I'm reiterating, even if you use DataFrames, which we are going to, after we go through concepts related to RDDs and APIs, those will be eventually converted into RDDs only. You need to keep in mind, at the lower level, everything will be executed using RDDs themselves. That being said, As we understood what RDDs are all about, let's also get into the details related to datasets and DataFrames. Then we'll actually get into details about how to create RDD. We'll also see how to process data in RDD using the low-level APIs, which are also known as RDD APIs. When it comes to Spark, there are three types of data structures. They are nothing but RDDs, datasets, and DataFrames. Already we got an overview about RDDs. Also, we'll go through quite a few important details with respect to RDDs in the rest of the module. With respect to other data structures such as DataFrames and datasets, I'll just cover theoretical aspects of it. There will be separate modules related to DataFrames. With respect to datasets, we will not be spending too much of time because when it comes to Python as a programming language, datasets are not relevant. Even though this module is dedicated to RDDs and APIs on top of RDDs, we will not be using RDDs to process data with respect to Spark applications. RDDs are considered to be low level and also complex. We should be able to build data engineering applications using Spark with DataFrames or Spark SQL much faster. That's why we'll be focusing on those quite a lot. But from the perspective of understanding the concepts and also from the perspective of interviews, having a bit of knowledge with respect to RDDs will definitely help. That's why we are spending quite a bit of time around RDDs. Let's get a quick overview about DataFrames and datasets. Then we'll actually get into remaining details with respect to RDDs and APIs on top of RDDs. When it comes to DataFrame, a DataFrame in Spark is a distributed collection of data organized into named columns similar to a table in a relational database. It allows developers to impose a structure onto a distributed collection of data, enabling higher level abstraction and easier optimization. When it comes to DataFrames, each and every column can be represented using name. With RDDs, it is not possible. That's why we prefer to use DataFrames to build Spark-based applications in case if you wanted to develop them programmatically, or we'll be using Spark SQL. When it comes to key features with respect to DataFrames, they are nothing but immutability and lazy evaluation, schema awareness, APIs across languages, also built-in optimization. With respect to immutability and lazy evaluation, like RDDs, DataFrames are immutable and lazy evaluated. Towards the end of this, we'll actually talk about lazy evaluation along with DAG. It means computations are optimized and executed only when an action is triggered. You will understand the details when we speak about DAG and lazy evaluation towards the end of this module. The second feature is nothing but schema awareness. The structure of data frame is known at runtime, which allows Spark to optimize queries better. The third one is nothing but APIs across languages. Data frames can be used in Python, Scala, Java, as well as R. Also, the fourth feature is nothing but built-in optimization. When it comes to built-in optimization, data frames use something called as Catalyst Optimizer. There will be a dedicated module or video with respect to Catalyst Optimizer. As we have gone through the definition and key features with respect to data frames, now it is time for us to get into details related to datasets. When it comes to datasets, they are a strongly typed JVM-based API available in Scala as well as Java. When it comes to Python and R, we will not be able to use datasets because Python and R are not strongly typed programming languages. We end up using data frames only when we use programming languages such as Python and R. When it comes to datasets, they are an extension of data frames that provides a type-safe object-oriented programming interface. Keep in mind, whatever features we have spoken with respect to data frames, they are applicable to datasets as well. However, the additional features are nothing but type safety, interoperability, and performance. With respect to type safety, datasets allow you to define the type of data in a strongly typed way, which can catch errors at compile time. When it comes to interoperability, you can convert data frames to datasets by defining a case class in Scala or a class in Java. This provides the flexibility of RDDs with the optimization benefits of data frames. When it comes to the third feature with respect to dataset, datasets provide the benefits of Spark SQL's optimized execution engine. Again, it is a feature of Catalyst Optimizer itself. So far, we have covered both definitions as well as key features related to data frames and datasets. Now, let's talk about usage scenarios. When it comes to data frames, they are best used when you need high-level abstractions and transformations working in Python or R, or when schema inference is required. Schema inference means determining both column names as well as data types based on the data. When it comes to datasets, they are preferable when you require type safety, working with complex data transformations in Scala or Java, or need the performance optimization of a typed API. Both DataFrames and datasets are integral to Spark's ability to handle big data efficiently, offering various capabilities depending on the specific requirements of the data handling task and the language used. If it is Python or R, we will end up using DataFrames. If we are using Java or Scala, we have option between using DataFrames versus datasets. Depending upon your needs, you can choose relevant data structures, and then you should be able to take it forward. This is about the datasets and data frames. Already we have spoken about RDDs previously. Now, as we spoke about data frames and datasets, let's get into remaining details with respect to RDDs and also APIs on top of RDDs to process the data. I hope you got an overview about RDDs, data frames as well as datasets. This video is all about RDDs. In case if you wanted to learn more about data frames and also Spark SQL, there will be videos in the description. Go to the description, click on the relevant videos and take it forward. We have covered all important aspects with respect to building applications using data frame APIs as well as Spark SQL. Also, if you are struggling to catch certain phrases, those will be covered in other parts of this video and also in other videos. Don't worry too much about some of the terms if you don't understand. We will also publish content around Spark architecture, DataBricks in detail, even Catalyst Optimizer to take care of the performance tuning. All these will be available as part of our channel. When we create the content and upload in our channel, if you want to get notified, don't forget to subscribe to our channel and also click on bell icon. If you start liking the content in this video, don't forget to like, comment and share. It means a lot for us. That being said, now let's dive deep into RDDs and also APIs on top of RDDs to process the data. In that process, we'll be learning quite a few important concepts with respect to Spark. When you attempt to create RDDs using low-level APIs, you need to use something called as Spark context. By default, when we use DataBricks, we have something called as Spark. You can add one more cell here. Then you can say Spark and run the cell. You can use Shift Enter to run any cell at any point in time. It will not only run that cell, it will also create a new cell. Now, if you see, when it comes to Spark session, it is nothing but Hive or Spark Metastore session. Also, it has Spark context inbuilt. In on-prem clusters with Hadoop and Spark, first we'll create a Spark object and then we'll invoke APIs using Spark object. The way we typically create Spark object is like this. First, we need to import something called as Spark session. It will start with from pyspark.sql, then import Spark session. Once Spark session is imported, then we typically say Spark equal to Spark session. It has something called as builder. Then using builder, we say app name. We should be able to specify the app name. Let's say getting started or word count using PySpark. So let me say word count, then PySpark. Then we say get or create. This is how we can actually start with creating the Spark object and then take it forward. However, with respect to this, where we are using DataBricks, we don't need to do this. We already have Spark object here. You can see we can directly access Spark without creating it. You can avoid developing code like this. Hence, let me clean up. Now, both the cells are cleaned up. On top of Spark, you also get something called as SC. SC stands for Spark context. You don't need to develop any code to expose SC. You can just try SC like this, and then you should be able to review the details. You can see it is of type Spark context. Spark and SC are automatically available for us when we use DataBricks. As soon as we launch Notebook, we should be able to use these without any issues. Keep in mind, we don't need to develop code to create Spark or SC. Now, when it comes to SC, there are quite a few low-level APIs. One of the APIs is nothing but text file. In case if you wanted to read data from text files, then you have to use text file. You can see here. Now I have selected text file. In case if you wanted to get help of this, you should be able to add question mark at the end and then run. As this is Python, this is how you can actually get help on functions. You can see the complete outcome with respect to this function that is available on SC. SC is of type Spark context. In that we have a function called as text file, and you can see all the details with respect to text file here. Let me scroll up here. Primarily, you should focus on this. You have a section which says load text file. You can see sc.textfile. The first argument is nothing but path. It is enough to pass one argument, which is nothing but path of the file. It will load the content from the file into Spark RDD. Once Spark RDD is created, you should be able to process the data. The way we typically process the data in RDD is by using APIs. On top of RDD, it exposes quite a few APIs. We just have to use those APIs to process data further. We will get into those details very soon. First, let's understand how to load the data from file into RDD. Then we'll get into APIs as well. Using the text file, which is nothing but Spark README, we'll take care of developing the program for word count. The location for Spark README is nothing but this one. DBFS DataBricks Datasets Spark_readme.md. Let's get into the details about how to read the content of this file into RDD. Then we'll explore APIs as well. Before using sc.textfile to read the content of this file into Spark RDD, first let us differentiate between file and RDD. When it comes to file, it is permanent. It is typically stored in shared location. It can be cloud-based storage or it can be distributed storage such as HDFS. In this case, this is in something called as DBFS. DBFS stands for DataBricks File System. When it comes to RDD, it is ephemeral or temporary. It is not permanent. It is in Spark framework as long as it is processed by Spark. Once the RDD is processed, it will be eventually flushed out of memory. So files are permanent and they are typically stored in cloud storage. RDDs are temporary. As soon as data is processed, they will be flushed out of memory. You need to make sure you have understanding with respect to difference between files and RDDs. That being said, let's go ahead and create RDD. For that purpose, first let's copy this path of the file. I'm taking a fully qualified path of the file. Now let me say sc.textfile. Let me specify the path. Here let me say lines equal to, then let me run this. So each line in the file will be considered as one element in lines. Lines is nothing but RDD. RDD is similar to array or list in Python. You should be able to get the count of the lines by saying lines.count. There is a function called as count on top of RDD. Now let's run this. You should be able to see the number of lines in the file. This file contains these many lines. The count is nothing but 95. Now let's check the type of lines. It is of type RDD. You can see here it is saying map partitions RDD. Don't worry too much about map partitions. You can see there is RDD in it. It means it is nothing but RDD. What is the full form of RDD? Resilient Distributed Dataset. In this case, when we use sc.textfile to load data from text file into RDD, it will load in such a way where each line in the file is element in this RDD. That being said, if you want to preview the data, this is how you should be able to preview. Let me say lines dot. Then you have a function called as first. It will get you the first line from the file. You can see the first line here. The first line is nothing but Apache Spark. We also have other functions. Let me say lines dot. Let's review the other functions. We have collect. Collect will actually convert the RDD into typical Python list. On top of this, we also have first. We have already seen first. Let me also scroll down and review other functions. In this case, I am looking from the perspective of previewing the data. I wanted to just get first few lines of the file. I think you should be able to use the take. Let me say take of 10. Let me run this. You can see first 10 lines from the file. Because take of 10 will convert first 10 lines in the RDD to a Python list. You can see the outcome here. It is in square brackets, which means it is of type list. So in case if you wanted to preview first few lines, you can use take. If you use collect, it will convert the entire RDD into Python collection, and then it will display as a Python collection or Python list. This is how you should be able to get started with creating RDD using the data in text files. We also have APIs to get data from binary files, but we'll keep the scope limited to text files themselves. Using the RDDs that are created on top of text files, we'll explore all important concepts such as actions, transformations, within transformations, wide transformations, as well as narrow transformations. Also, we'll get into details related to shuffling and many other aspects. Keep in mind, this is a very, very important video which covers quite a few fundamental aspects of Spark. Make sure you watch each and every topic that is covered in this video so that you are fairly comfortable with Spark. Unless and until you understand the topics that are covered in this video, you will not be able to understand the advanced aspects of Spark. Let's make sure we understand all the basics before we get into the advanced aspects with respect to Spark and also building applications using Spark. I hope you are enjoying the content that is covered so far. Also, stay tuned for rest of the aspects with respect to basics of Spark. In case if you start liking it, make sure to like, comment and share with your friends. Also, subscribe to our channel and click on bell icon so that you are notified whenever we upload fresh content. In case if you are looking for advanced aspects with respect to Spark, look at the description. We have links with respect to all the content related to Spark which we have published already. You should be able to explore whatever you are looking for. We have topics such as Delta Lake. We have topics which talks about Spark SQL, PySpark APIs, and also performance tuning with respect to Spark. Also, we have covered quite a few important aspects using the full version of Spark. You should be able to explore all those aspects by looking at the description. Don't forget to look at the description and learn a lot more cool stuff which are already covered as part of our channel. As we have understood how to read data from files into RDD, now it is time for us to understand APIs that are available on top of these Spark RDDs. We should be able to copy this RDD name here. It is nothing but lines. Then paste, then say dot. You should see all the APIs or functions that are available on top of it. You have aggregate, aggregate by key, then collect, then count, combine by key. Then you also have distinct filter, first FlatMap. There are a bunch of them. However, all these APIs or functions are divided into transformations and actions. Some of these are transformations, some of these are actions. We will understand what transformations and actions are all about, but this is how you can get started. In case if you want to get help on any of these functions, this is Python after all, hence you should be able to say help, then whatever is the RDD name, then dot, then function, let's say count. Now you should be able to run this, and then you can review the details with respect to this count function which is available on top of RDD. In the similar fashion, in case if you wanted to get help on other functions such as filter, map, etc., again you should be able to use help, then specify the RDD name, then specify the function name. Let me say filter. Let's run this. You should be able to see the output. When it comes to functions such as filter, map, etc., they take lambda function as argument. Hence, you should be fairly comfortable with the Python's lambda functions to leverage these functions and take it forward. That being said, this is how you should be able to start with APIs or functions that are available on top of Spark RDDs. You just have to specify the RDD name, then dot. It will automatically list all the functions that are available. If you are using DataBricks Community Edition, you can review the functions, pick whatever you want, seek the help by using help function, and then start using it by incorporating as part of your applications. When it comes to APIs or functions on top of RDDs, they are grouped into two. They are nothing but transformations and actions. Examples for transformations are nothing but these ones: filter, map, group by key, reduce by key, reduce, and many more. On top of transformations, as I have mentioned to you earlier, there are a group of APIs or functions which are also known as actions. Examples for actions are nothing but count, then collect, first, take, also save as text file, etc. First, let's get into actions, then we'll talk about transformations. While talking about transformations, we'll also get into details about narrow transformations, wide transformations, etc. Already we have seen a couple of examples with respect to actions. You can see here we have previewed the data using a take, and also we have used first to get first record from the RDD. On top of these two, we have even reviewed count. Count actually gave us the number of records we have in the RDD. So three of these are already seen: count, first, and take. On top of these, collect is another popular one. When it comes to take, depending upon the integer argument you pass to it, those many number of elements in the RDD from the top will be converted to Python list, or if you are using Scala, Scala list. But when it comes to collect, instead of only picking the number of records based on the argument passed, it will convert the entire RDD into Python collection or Python list. If it is Scala, it will be Scala based collection. That being said, when it comes to usage with respect to collect, it will be something like this. You have the RDD name, which is nothing but lines, then collect. You have to have brackets at the end, then run. Then you will actually see the content of lines displayed here. You can see here, this is nothing but list. That's why you see square bracket at the beginning. Then you have elements enclosed in a single quotes. All of these are of type string. Then you have commas at the end. In this list, you have elements which are mapped to lines in the file. The first line in the file is the first element in the list. Then second line in the file is the second element in the list, so on and so forth. So from file, we have created RDD. From RDD, if you want to build Python native collections, then you use collect function. Typically, we use first and take to preview the data, count to get the count. As we have seen earlier, first will get the first record from the RDD. Take will get first n number of records from RDD. In case if you wanted to process the data in RDD further by using a Python-based approach, then we convert the RDD into Python list, and then we use Python native capabilities to process further. Make sure you understand the relevance of all these four important functions which are categorized under actions. As mentioned earlier, we will see examples related to save as text file at a later point in time. That being said, as we got an overview about transformations and actions, and also as we have understood actions better, now it is time for us to get into transformations. We'll be spending a bit more time in transformations compared to actions, because for most part of it, we'll be using transformations to actually process the data. As we get into transformations, we should be familiar about quite a few concepts as well as terms. Let me first highlight those, then we will dive deep into those. The first term or concept which you should be familiar about is nothing but narrow transformations. Then we have wide transformations. On top of narrow and wide transformations, you should be even familiar about a concept called as shuffling. It is very important for you to understand what shuffling means. On top of this, you also should be familiar about a very important term called as DAG. DAG stands for Directed Acyclic Graph. This is a very important term or phrase which you should be familiar about. Then you have another important phrase, lazy evaluation. Unless and until you are familiar about these three, you will not be able to understand wide transformations and also the difference between narrow transformations and wide transformations. When it comes to narrow transformations, the examples are nothing but filter, map, FlatMap. These are narrow transformations. These are nothing but APIs on top of RDDs. When it comes to wide transformations, the examples are nothing but groupByKey, reduceByKey, and there are few more, but these are the most popular ones. We also have another important wide transformation, which is nothing but reduce. These are some of the wide transformations and narrow transformations. There are quite a few others as well. Based on our need, we'll explore whatever we wanted to explore. And based on your requirements, once you get into projects, you should be able to do the required research and take care of additional narrow or wide transformations which are not covered as part of the course. That being said, as we have gone through quite a few important concepts and terms related to transformations, now let's start with narrow transformations. We'll be using word count as an example. Then we'll actually get into other type of transformations. Finally, we'll get into developing the complete program related to word count. As we have understood all the important terms and concepts related to transformations on top of Spark RDDs, now let's start exploring narrow transformations. However, before getting into transformations on Spark RDDs, you should be familiar about Lambda functions in Python. In case if you are new to Lambda functions in Python, feel free to reach out to us. We will provide the direction. You have to first learn Lambda functions, and then you should take your journey with respect to transformations forward. That being said, now let's review the help on filter function. Then we'll take it further. Already we have lines, which is nothing but RDD. We should be able to specify filter like this. Then we should be able to see the help related to filter. When it comes to filter, it takes Lambda function as argument. You can see here. Now let's review the data in lines. You see we have all these elements in lines. There are quite a few empty strings in lines. We just wanted to filter out these empty strings. So whatever are empty strings, we don't want to consider them. We wanted to consider only those strings where we don't have empty lines. Now you should be able to come up with logic like this. In this case, we can say lines.filter, then lambda. You have to give a name to each and every element with respect to these lines. Hence, you can say line or L here. Whatever is your preference, you can stick to it and take it forward. When it comes to this line, it is of type string. Because we have used sc.text file to pass the path from where we have created this RDD by name lines. Each and every element in the RDD when we use text file will be of type string. Hence, we should be able to use any of the Python string functions to achieve whatever we are looking for. In this case, we wanted to compare whether each of these lines are equivalent to empty strings. For that purpose, we just have to say line double equal to empty string like this. This is how you should be able to filter for only those lines where we have empty strings, but our requirement is to get those lines where the lines are not empty string. For that purpose, we have to use not equal here. Now we should be able to run it. However, to preview the data, either you have to use first or take. In this case, I'll be using take. When it comes to take, it takes an integer as argument. Let me say 10, so that we can preview the first 10 records after filtering where the line is not equal to empty string. Now let's run this. While it is running, let's go up and review the data. You can see the second line is empty string. This is empty. And also this is empty. I think this is 9th line. Then we have 11th, 12th, which are also empty strings. Now let's scroll down. We should not be seeing those empty strings in the outcome. You can see when it comes to second element in this new RDD, which is created because of the filter, it is not empty string anymore. On top of take, you can also use count to validate. Earlier we have seen 95 as count. Now let me copy paste here and use count on top of filter. Let's see the new count. It should be less than 95. You can see it have returned 60. When it comes to RDDs, they are immutable. A new RDD will be created when we use functions such as filter, map, or any other transformation. On top of these narrow transformations, we should be able to use count functions to get the count at any point in time. This is how you should be able to use filter to filter the data in RDD and create a new RDD. Let's also get into details about how we typically come up with Lambda functions in functions like filter. So with respect to filter, we need to make sure the body of the Lambda function always return true or false. In case if the logic in the body doesn't return true or false, either it will fail or it will start giving incorrect results. You have to keep this in mind. The body in the filter should always return true or false. What happens when we use filter? If for each and every record the expression return true, then it will be considered into a new RDD, otherwise it will be discarded. By the end of the execution of filter, we will only have those elements in the new RDD where the conditions are true. The other elements will be discarded. Keep in mind, you cannot apply any transformations on top of these elements in RDD while using filter. When I say transformations, in case if you wanted to convert the text into uppercase or lowercase, or if you wanted to perform some other kind of transformations to manipulate the data in the RDD, it will not work with filter. You have to use map for that. Now it is time for us to get into details related to map. As we have understood quite a few important details related to filter, now it is time for us to explore map. Map is also categorized under narrow transformations. Many times we might want to manipulate each and every record. At that time we use map. First let's start with help and then we'll take it forward. In the similar fashion as filter, you can say help of, then lines, which is our RDD, then dot, then map. Let's run this. You can see the outcome here. If you want, you can read through this so that you understand what is going on here. However, you can directly go to example here. This is the example for map on top of RDD. You can see even map takes a Lambda function as argument. You can see here. However, when it comes to body of the Lambda function, instead of having condition, we'll have some row level transformation logic. When it comes to row level transformation or record level transformation, it means manipulating data from one form to another. If we take the example of elements in lines where we have strings, we might want to manipulate each and every element to convert to uppercase or lowercase, or you might want to remove spaces. All these are categorized under row level or record level transformations. That is where we typically use map. Now let's come up with a logic where each and every string is converted to uppercase. I should be able to say lines dot map, then lambda, then name of the argument. Let me name it as line. You can also use L or whatever you want. Then we should be able to say line dot upper. In this case, upper is a function on top of string that is available in Python. We can use all those string manipulation functions without any issues in case if you wanted to use those. Now we should be able to say dot take of 10 to see if all the strings are getting converted to uppercase or not. Now you see, earlier we have Apache Spark where A and S are capital but remaining characters are in lowercase, but now everything is in uppercase. Same is the case with here. You can preview the data here and compare. This is how you should be able to use map to perform row level or record level transformations, this is typically done on top of RDD. That being said, now let's also look at combining filter and map. For example, let's say I wanted to discard all those lines where they are empty, and then I wanted to perform row level or record level transformations on remaining records. In that scenario, I should be able to come up with a logic like this. I can say lines, then filter, lambda, line, then line not equal to empty string. Then I wanted to apply map to convert each and every string in the filtered RDD into uppercase. I should be able to use the logic which we have specified here. Then we should be able to say take of 10 to preview the new data. In this case, we should be seeing all the records in uppercase. Also, all the records where we have empty strings will be discarded. Let's run this and review the outcome. You can see the outcome here. All those elements which are empty strings are gone. So we have combined filter and map here. Before moving on further, let's also get the count on top of the result here. Earlier we have 95 in lines. When it comes to map, it will not be discarding any of the elements. Hence, the count will be same after converting each and every element to uppercase using this map function. You can review the details. You see it have written 95. In the similar fashion, if you use count on top of it, it will return 60 because we have filter. This itself will return 60. On top of those 60 record RDD, we are applying the logic to convert it to uppercase. Hence, only those 60 records will be converted to uppercase. Hence, if you perform count on this logic, you will be getting 60 as outcome. As we have covered filter and map, now it is time for us to cover FlatMap as well. FlatMap is very, very important narrow transformation when it comes to word count. If you don't use FlatMap, you will not be able to get word count for our data. Hence, we'll get into the details related to FlatMap. After that, we'll actually get into wide transformations. While going through wide transformations, we'll also cover the important concepts such as shuffling, DAG, and lazy evaluation. At this time, we are going through the details related to narrow transformations. Already we have covered filter and map. Also, I have emphasized on coming up with a program for word count. Even though I have used the word count term many times, I haven't covered what word count means. Unless and until you understand what word count means, you will not be able to relate to these important concepts which are being covered here. Now, let's spend some time in understanding what word count actually means. Word count means in the file we have several words. Each word is separated by space or even a Newland character. You wanted to see how many times each of the words in the file are repeated. That is what word count actually means. For example, let's assume we have only these 2 lines in the file or these 3 lines in the file. In these 3 lines, Apache is repeated only once. Hence, for Apache, the count is 1. When it comes to Spark, it is repeated twice. You can see here. So with respect to Spark, the count is 2. Then we have is, which is repeated only once in these 3 lines. Hence, it is 1. When it comes to A, it is also 1 because it is repeated only once in the 3 lines. Fast is also 1, and is also 1, so and so forth. So word count means in a given file, how many times each and every word is repeated. Here, when it comes to developing a word count program, the final outcome will be whatever words we have in the file, we also will have count associated with them. These results will be saved to files. In the file, you will have word and its corresponding count in each and every line. We will also get into details about how to preview this data before actually getting into writing to file. Also, after writing to file, we'll also see how to validate whether data is returned to the file as per the expectations or not. In this process, we'll also understand how to sort the data in case if you wanted to have the words with the top count at the top and then the remaining data in descending order. All these details will be covered when we get into other topics with respect to APS on top of Spark RDDs. Stay tuned and learn all important aspects with respect to concepts as well as APS to process data using the low-level data structures and APS in Spark. Before getting into FlatMap, let me revisit some of the important functions on strings, then we'll take it forward. First, let me pick one of these strings. Probably this is better. Let me take this one. Let me define a variable by name yes. Then let me add the string in single quotes and then run this. It will take care of creating a variable by name yes, which is of type string. This is a Python string. This is nothing to do with Spark. You can check the type by saying type of yes. Type is a function in Python which actually gives us the data type of the variable which is passed to it. You can see s is of type string. Now if I say s dot, you can see there are quite a few functions available on top of yes. You have count, which actually return number of characters in the string. Then you have is alpha to check if all the characters are alphabetic or not. Also you have other functions such as lower, upper. You can see upper here. Also you have another very important function which is nothing but split. When it comes to FlatMap, split is more relevant. We'll get into split very soon. But first, let's also review other functions that are available on top of string. Already we have seen lower or upper. Actually, when I spoke about map, I have covered how to convert the data in RDD to uppercase using upper. The same can be used here. You can see here. S.upper have converted the entire string to uppercase. In case if you wanted to convert the entire string to lowercase, you should be able to say s.lower. Now you see the outcome is all in lowercase. You can see here with respect to Spark streaming, S is capital. However, here it is in lowercase. Both in Spark as well as streaming, the S is converted to lowercase because we have used lower function. All the characters in S are now in lowercase. Then comes len. Len is the first class function. You don't invoke on top of yes. You just have to say len and then yes. It will get us the number of characters in the string. This string is of length 42 characters. You can see here. Then we also have count. However, the count will actually return how many times a particular character or substring is repeated. So in this case, if you wanted to see how many times streaming is repeated or stream is repeated, let's focus on stream because it is repeated twice. You should be able to say s.count of stream. Now let's run this. You can see the count is 1. The reason why count is 1 is because with respect to streaming here, S is in uppercase. It is only factored this one in. It haven't factored this one in. To ensure this is also factored in, what you are supposed to do is you have to say s.lower, then count, then stream. This time you see it have returned 2. In the similar fashion, if you wanted to see how many times S is repeated, you should be able to use this logic. S.lower, then dot, then count of yes. You can see it is repeated 5 times. These are some of the important functions on top of yes. Count, lower, upper, etc. There are quite a few others also. But the most important one with respect to FlatMap is nothing but split. If you look at the help related to split, it actually splits a string into Python list by using delimiter. You can see it takes separator as argument or delimiter as argument. Then it will actually split the entire string into list of multiple substrings. You can see here. When it comes to split, it return a list of the substrings in the string using sep as the separator string. In this case, let's assume space as separator. Then if you say s.split of space, you see it have returned a list. This is nothing but list. This list contain 6 elements. End is first element in the list. Then Spark is second element in the list. Streaming is third element in the list, and processing is sixth element in the list. This is how you should be able to use split to split a string into list of substrings. Why I am covering this before getting into FlatMap? When it comes to input RDD to FlatMap, we need to have RDD where each and every element is list of strings, not string themselves. We will not be able to use FlatMap on top of lines. First, we have to use map, convert RDD into new RDD where each element in RDD is of type list of strings. Then on top of it, we should be able to use FlatMap. Don't worry too much if you don't understand at this point in time. As we proceed further and start exploring these APIs from the perspective of word count, all the concepts should be clear to you. I hope you are enjoying the course. If yes, don't forget to like, comment and share with your friends. Also, don't forget to subscribe and hit on bell icon. That way, you will be getting notified whenever we upload fresh content into our YouTube channel. That being said, if you are struggling, the root cause might be you might be learning Spark directly without learning Python. If that is the reason, look at the description. We have videos related to Python for beginners and also Python essentials for data engineers. You should be able to go through those videos and you should be able to be up to speed with respect to Python that is required to develop applications using Spark. When it comes to Python for beginners, you will just understand the fundamentals of Python. Everyone should go through it. Once you go through it, if you go through Python for data engineers, you will actually understand how Python is used in data engineering itself. It covers a wide array of topics that are relevant for data engineers. It includes Python collections very extensively. Also, it includes pandas, which is another important library on top of Spark to process data when data is lightweight. On top of these things, you will also understand how to interact with the databases using Python. Make sure you take up that course in case if you are struggling to understand whatever is going on here. So once again, I am reiterating, you have to take 2 courses. The first one is nothing but Python for absolute beginners, where you will be learning fundamentals of programming using Python. Then second course is nothing but essential Python for data engineers. In that, you will be learning collections, pandas, database programming, including a couple of projects. So far, we have covered APIs or functions such as filter and map on top of Spark RDDs. Now, we have to take it further and explore FlatMap and reduceByKey for the word count. However, before taking it further, I wanted to cover important concept called as aggregations. We perform aggregations quite a lot on top of Spark RDDs or even Spark DataFrames. For now, we'll focus on Spark RDDs. Before actually getting into the functions to take care of the aggregations, I would like to cover the concept of aggregations. Let's take the same example, which is nothing but library. We have spoken about it earlier. And if you wanted to get total number of books in the library, it is nothing but aggregation. The count is the aggregate function. Then you might also want to get total number of books based on a given title, which is nothing but atomic habits. That is another aggregation. Also, when it comes to library, the library might be making revenue using multiple revenue streams. One can be subscriptions and another can be rental. If you want to understand how much revenue it have made using subscriptions for the month of June 2024, it is another aggregation. Or the total revenue based on rental of the books for the month of June 2024, it is also aggregation only. On top of these, you also might want to compute minimum revenue or the title which generated minimum revenue or maximum revenue. Even these are nothing but examples for aggregations. So aggregations are nothing but performing operations such as count, sum, min, max, average. When it comes to a bit advanced, we also might be focused on standard deviation and quite a few other aggregations. But count, min, max, total and average are the common aggregations which we typically perform. So far, whatever examples I have covered are related to total aggregations. We are just talking about total count or total sum or min of some subset or max of some subset, so on and so forth. Many times we will be performing aggregations based on certain case. You might want to get a number of books based on each title or each genre such as romance, comedy, fiction, etc. In the similar fashion, you might want to get revenue within a year for each month. Again, as you are going to compute total revenue per month, it is kind of a aggregation based on certain key. So these are two types of aggregations which we perform: total aggregations and then aggregations by key. That being said, when it comes to total aggregations with respect to Spark RDDs, we use a function called as reduce. When it comes to aggregations based on key, we use a function called as reduceByKey. Also, we have something called as groupByKey, which is not used very often, but if you want, you can also use groupByKey to perform certain operations based on each key. However, when it comes to the course, reduce and reduceByKey are relevant. You need to understand when should be used what. Reduce should be used for total aggregations. reduceByKey should be used for the aggregations that are supposed to be performed by each key or each category or each group. Whatever term you want to use, you can use. You might already be familiar about this when it comes to APIs or functions in Spark, especially to process data. The APIs or functions are categorized under narrow transformations or wide transformations. Map and filter are narrow transformations. Whatever I have spoken in this video earlier, which are nothing but reduce, reduceByKey, groupByKey, these are categorized under wide transformations. Wide transformations involve shuffling. What is shuffling and why these are known as wide transformations? We'll cover those details at a later point in time. Before getting into word count using FlatMap and reduceByKey, let's explore reduce a little bit so that you understand the importance of it. Then we'll get into word count again, where we'll be talking about FlatMap followed by reduceByKey. That being said, let's dive deep into reduce and then we'll take it further. Yeah, we have gone through details with respect to map, filter, and also concepts around aggregations. Now it is time for us to get into details related to reduce function. As usual, we'll start with help and then we'll take it forward. Let me scroll down here. We should be able to say help. Then lines. Lines is the main RDD. We haven't filtered any data in lines. Now let me say reduce. Let's run this. You should be able to see the help related to this function. You can see the definition and all the details here. Towards the end, you can see the example also. Here is the example. First, add is imported and then RDD is created using this approach. You can use sc.parallelize to create RDD using Python list. This is the example for that. On top of it, reduce is used. However, in most of the cases, we'll not be getting data in this format where we have numbers. To perform any aggregation operation, we need to have numbers. Unless we have numbers, we will not be able to perform aggregations such as count, sum, min, max, etc. That means after reading the data from file, we need to ensure we generate numbers, and then using the RDD with numbers, we should be able to use reduce to perform aggregations. In most of the cases, reduce is preceded by map. Using map, we'll get the numbers from the original input data. Using those numbers, we'll invoke reduce to perform any aggregate operations such as count, min, max, sum, etc. Now, let's take the example of lines. Lines is RDD, which is created based on Spark readme.md in DataBricks Datasets. Let's preview the data first. I'm saying lines.collect. We should be able to preview all the records in this RDD. The first record is nothing but this one. Then second is nothing but this one. The third one is nothing but this one. Let's say we wanted to compute total size of the file or total number of characters in the file. Each line have certain number of characters. First, we need to get the number of characters in each line. Then using that information, we should be able to use reduce to get total number of characters in the file. Now let me scroll down here. In this case, I should be able to say something like this: lines.map, because the input contain the strings. Now we need to make sure these strings are converted to numbers. In this case, using the string function len or using the len function, we should be able to get number of characters in each string. Hence, I should be able to say lambda, then L or line. Let me say line, then len of line. Now let me first preview this data. Let me say dot take of 10. It will only get us first 10 records lengths. You can see the outcome here. Now the first record in the RDD or the first line in the file contains 14 characters. The second record or line contains 0 characters. The third one contains 78 characters. The fourth one contains 75 characters, so and so forth. You can see number of characters of each record in RDD here. Here we are displaying only first 10. Now we want to get total number of characters. That's where we should be able to use reduce. We should be able to copy this, then paste. Before invoking reduce, I also wanted to import add function. Let me say from operator import add. Operator is Python module. It have functions such as add, sub, mul, div, etc. These can be used for arithmetic operations. Here we are using add. Now we should be able to say reduce, then invoke add. It will take care of computing the total number of characters in the RDD. Now let's run this and see the outcome. You can review the result here. It have 3264 characters. When I say it, I am talking about RDD or even the file. So the file spark readme.md have 3264 characters. This is a small file, hence it ran pretty fast. Even if you use plain vanilla Python, you should be able to get results at the same speed. However, if the file size is very big, that's where Spark comes handy. These will start showing good results only when data is large enough. For small dataset, you should not be using Spark. You might have to consider libraries such as Pandas. Keep in mind, reduce is a Spark function. It is available on top of Spark RDDs. It is categorized under wide transformations. Wide transformations involves shuffling. Stay tuned to understand more about wide transformations and shuffling. For now, let's move on to FlatMap so that we can take care of word count while learning all the key concepts of Spark and also the APIs on top of RDDs. After going through transformations such as filter map on Spark RDDs, we have detoured a little bit from word count and explored string functions in Python, and also we got into details such as aggregations and reduce function. Now let's go back to word count. From the perspective of word count, the next transformation which we should be exploring on top of Spark RDDs is nothing but FlatMap. Let's go back where we have used split on top of string. This is where we have reviewed split on top of string. We have created a string by name yes. We have assigned a value like this, and then we have used split to actually convert the string into list of substrings like this. Now we need to make sure we generate RDD which contain records like these. Instead of having strings like this, we need to make sure we have a list of strings like this in RDD. Once we have input RDD where each element is a list of strings, then we should be able to use FlatMap. FlatMap is primarily to flatten these lists into individual records. Once we go to the example, you will understand what we are talking about here. First, let's review the outcome of lines.collect. You can see all the elements in the RDD. Now we should be able to use map on top of lines, then say lambda line, then line dot split. Using space, we are attempting to split each and every line. Now let's say take of 10. Let's run this. You can see the first 10 elements in this new RDD, and if you observe, the first element in the RDD is of type list. Earlier it was string. The string is converted to list of substrings. The list contains 3 elements because the first element in the original RDD contains 2 spaces in it, one after hash, then another one after Apache. Using a space as a separator or delimiter, the first record in the RDD is converted to list like this. When it comes to second element in RDD, it is empty string, hence we have only one element in this list. When it comes to third element, it have quite a few words separated by space. This list related to third element contains quite a few substrings. This is how you should be able to convert the RDD which contains strings into RDD which contain lists. Now it is time for us to use this input RDD which contain lists to flatten by using FlatMap. The way you can use FlatMap is like this. Let me first copy this. Let me paste. Let me format this little bit and then let me try using filter here. In this case, I'll be skipping the empty lines. Hence, I'm saying lambda line, then line not equal to empty, then dot, then backward slash, then backward slash here. Already we have invoked two functions, filter and map. Filter to filter the data which we don't need, then map to actually convert each and every line which is not empty is converted to list of strings. On top of this, we should be able to use FlatMap. Unlike filter and map, with respect to FlatMap, you don't need to pass any functions. You just have to invoke like this. Then let's run this. However, it have failed. It is expecting an argument, which means I am wrong. Let me add a code cell here. Let me say help. Then let me say lines.flatmap. Now let me run this to review the syntax. When it comes to FlatMap, we need to pass the lambda function the same way as we have done earlier. Probably what we are supposed to do is this one. We can just say lambda, then line, then line. Let's see what happens. It is working as per the expectations. Instead of using map and FlatMap separately, we might be able to use FlatMap directly. It's been a while since I have used RDD APIs. That's why I missed this part. I think as per the syntax, you can actually apply this logic within FlatMap itself. Let me copy this. Let me paste here. Now let me delete this. Now let me run this. You can see the outcome here. It is working as per the expectations. So whatever I have explained earlier, I'm a bit incorrect. You don't need to have input RDD which contain lists as elements. You can have input RDD which contain strings as the elements. However, you need to apply the split logic to convert each of the strings into list of substrings as part of the FlatMap itself. So in this case, we have used filter to filter out those records which are not required. Then we have used FlatMap to flatten each and every string into multiple substrings. Now let's also get the count on this to see how many records we have. Originally, with respect to lines, we have 95. Then after filtering out empty lines, we have 60. You can see 60 here. We have applied FlatMap on top of the RDD which contain these 60 records. Let's see how many records FlatMap have resulted. For that, we should be able to copy this, paste here, and then say count. After flattening, we have these many records. We have 472. So we have total 472 words. Using these 472 words, we have to compute word count. That's where reduceByKey comes into play. ReduceByKey is nothing but wide transformation similar to reduce. The main difference between narrow transformations and wide transformations is nothing but shuffling. Now it is time for us to explore the concept of shuffling. As we have discussed earlier, the transformations in Spark are grouped under narrow transformations and wide transformations. What are the examples for narrow transformations? Filter, map, FlatMap, etc. When it comes to wide transformations, the examples are nothing but reduce, reduceByKey, groupByKey, etc. What is the difference between the two? The main difference is nothing but shuffling. Now it is time for us to explore the concept of shuffling. We are using a library to understand some of the concepts such as distributed computing. We can consider it as case study. Within library as case study, we can quote quite a few examples when it comes to understanding concepts such as shuffling. I'll be talking about quite a few examples. The first one is nothing but getting all the books with the title Atomic Habits. That is the first example. Second example is nothing but getting a number of books with the title Atomic Habits. Then the third example is nothing but getting number of books per genre. When I say genre, I am talking about romance, then comedy, fiction or science fiction, so on and so forth. You might want to get number of books in each and every genre. That is another example. Now, if it is a library with 60,000 books, if one individual have to search for all the books with the title Atomic Habits, it will take its own sweet time. Let's assume it take 10 hours to get the books with the title Atomic Habits that are spread across the library. If you have 10 people and if library is divided into 10 rooms, if each person go into specific room and search for it, then the results will be much faster. You will be able to search for all the titles associated with Atomic Habits or all the books with the title Atomic Habits within 1 hour if 10 people are searching in the library, assuming each and every person have same level of capabilities. If you understand this example, each person might get one book or 0 books or even more than one book depending upon how many books are there with the title Atomic Habits in those 10 rooms. Finally, these results have to be consolidated to get all the books with the title Atomic Habits in one place. So there is a process of consolidation also. In this example, each of the person will just dump the books they find in one centralized location. That is where the functions like collect or take comes into play. With this, we don't need to do any explicit grouping. It is just consolidating all the books at one place. So there is no shuffling involved at all. Now, in other examples such as getting a count, where we are trying to get the total number of books with the title Atomic Habits, even there we don't need to involve any shuffling. We just dump the books in one basket, common basket, and if we perform the count on it, we should be able to get the result. No need of shuffling or no need of consolidation. Now, let's take the third example. The third example is nothing but getting number of books by genre. So each individual go into their own room in the library. We have 10 people and we have 10 rooms. Each one will go to their respective room. And in that room, as they glance through the books, they have to identify the genre and they have to compute intermediate results. So within each room, how many books are there based on comedy, based on romance, based on fiction, so on and so forth. Here, each individual is performing 2 operations. One, grouping the data by genre and then performing the count. So after processing, each individual will get the intermediate results where they'll get genre and the count with respect to that genre in each of the room. Now, these results have to be consolidated, which means after processing the data within rooms, some of the individuals have to get the intermediate results and then they might have to come up with the final count. This process of grouping the data, computing the intermediate results, and then consolidation is nothing but shuffling. Now, when it comes to functions like filter, map, or even FlatMap, there is no shuffling involved at all. But when it comes to functions like reduceByKey, groupByKey, etc., there is shuffling involved. If a given transformation on Spark RDD or DataFrame involves shuffling, those are known as wide transformations. If the transformations doesn't involve shuffling, they are known as narrow transformations. When it comes to the first example where we are looking for the book such as Atomic Habits, there is no shuffling involved at all. Each individual can go into their own room and then identify Atomic Habits, dump them in a common basket. That's it. There is no consolidation by grouping the data again based on certain key and take it forward. Hence, there is no shuffling involved with functions like filter or map, but with respect to functions like reduceByKey, groupByKey, there is shuffling involved. That's why they are categorized under wide transformations. I hope you understood this very important concept of shuffling and also the difference between narrow transformations and wide transformations. How shuffling is taken care of in Spark, we'll get into those details when we review the Spark architecture at a later point in time. For now, let's get into the details related to how to get word count using a wide transformation called as reduceByKey. With respect to Spark RDD APIs, so far we have covered filter, map, reduce, and also FlatMap. Now it is time for us to get into the next function, which is nothing but reduceByKey. ReduceByKey is wide transformation. It involves shuffling. First, let's start with the syntax and we will take it further. In this case, I'm using lines as the RDD on which I want to see the help related to reduceByKey. Let me pass this to help function. Let me say help, then in brackets lines dot reduceByKey. Now let's run this. We should be able to see the documentation here. You can see with respect to this one, the definition is nothing but merge the values for each key using an associative and cumulative reduce function. Or commutative reduce function. It's not cumulative reduce function, it's commutative reduce function. The examples for commutative reduce functions are nothing but add, min, max, average, so on and so forth. Now let me scroll down to an example here. You see in this example, first here an attempt is made to create RDD. The list on which the RDD is created contains tuples. So you have to use the list of tuples to create RDD so that we can explore reduceByKey function. Already we have covered quite a few important details with respect to lists and tuples earlier. If you observe this, the list that is passed here to sc.parallel to create RDD contains tuples. So you need to have tuples when it comes to RDD on which you want to use reduceByKey. However, whatever we have seen earlier in the pursuit of word count doesn't have tuples. Now let me actually copy this. Let me make sure the results are assigned to variable called as words. Let me run this. Now with respect to words, it is of type RDD, but each element is of type string, not tuple. As it is successfully run, let me say words dot take of 10 so that I can preview first 10 records. You can see simple words in words. You have hash, and then you have Apache, you have Spark, so on and so forth. So each of these are nothing but strings. However, we need to have tuples like this to use reduceByKey to compute word count. It should be like this. For hash, which is nothing but first record in words, it has to be comma 1 so that these ones are added to compute word count. Then with respect to Apache also, again there should be a tuple. The first element should be Apache, then the second element should be 1. Then another tuple for the third word, which is nothing but Spark. So the first element in this tuple is nothing but Spark, then the second element is nothing but 1. In the similar fashion, we need to have tuples for each and every of these words. For that reason, again, we need to use map function. We need to convert these strings to tuples so that we can invoke reduceByKey on top of the RDD. So the way it will work is like this. We have to take words, then we have to use map function. As we have seen earlier, map function takes another function as argument. It can be lambda function. We can say lambda, then word comma 1. It means each and every word will be transformed to tuple. If you wanted to preview, you can just say take of 10 and you can run it. You can see the outcome here. All the words are converted to tuples. Now we have RDD of tuples. Using this RDD of tuples, we should be able to invoke reduceByKey. That being said, let me copy this. Let me say word tuples equal to whatever logic we have come up with. Let's run this. Now word underscore tuples is RDD which contain tuples. Using this, we should be able to invoke reduceByKey. Let's review the syntax with respect to reduceByKey. When it comes to reduceByKey, we just have to pass a function as argument. It can be a lambda function or it can be operator functions such as add. In this case, we'll be using add because we just have to add these ones to get word count. Now let me scroll down here. Let me say word underscore tuples, then reduceByKey. Then I have to invoke add. For that, I need to make sure add is imported. Let me include this also from operator import add. I wanted to preview the data. For that reason, I am saying take of 10. Now let me run this. Let's see whether we will be able to get word count for each of the words or not. You can see the details here. In case if you wanted to sort the data before previewing, you can use the sortByKey function as well. I'll be covering it at a later point in time. For now, this is how you should be able to use reduceByKey to get the word count. You can see the outcome here. When it comes to the entire file, which is nothing but spark readme.md, hash is present only once. Even Apache is present only once. When it comes to Spark, it is repeated 13 times. However, when it comes to the logic, I wanted to ensure case sensitivity is not considered. I would like to convert each and every word to uppercase, and then I wanted to perform word count. For that reason, instead of just saying word comma 1 like this, I'll say word.upper, because word is of type string. Strings have a function called as upper to convert the content of string to uppercase. Hence, I am specifying like this. So every string will be converted to upper before creating the tuples with the uppercase string along with 1. Now let me run this once again. This time the tuples will have words in the uppercase. Now let me run this to actually see whether the data is converted to uppercase or not before getting word count. You can see here it is as per the expectations. That being said, let me also get the total count of these tuples where we have not only words but also the count of each of these words. The way you can get the count is like this. Let me paste. Now let me say count. Let me run this. You should be able to see the number of words. We have 245 unique words in the spark readme.md. Here we are able to see count of each and every word that is there in the file. I am previewing only 10 records. If you want to preview all 245 records, you can use collect. Let me copy this and then let me use collect in place of count to preview all 245 records. Now you should be able to see all 245 records along with the corresponding count. This is how you should be able to achieve word count. In this case, after generating RDD with words, we have invoked map function to convert individual words to tuples, and then we have used reduceByKey to perform aggregation to get word count. Make sure you are fairly comfortable with using multiple functions to achieve whatever is required as per the requirements. Also, we will see how to sort this data, and also we'll go through the details about how to write the processed data into files, all using Spark RDD based APIs. As we have gone through details about how to get word count, before taking it further to revise, let's also focus on how to sort the data in desired order. When it comes to examples like word count, people might prefer to sort data in ascending order by words, or it can be either in ascending order or descending order by count. We use count as criteria to get the most popular words at the top or at the bottom. Keep in mind, both the choices are very popular, whether to sort the data alphabetically in ascending order or to sort the data based on count either in ascending or descending order. Let's take the example of sorting the data in ascending order by words. We'll also go to the details related to sorting the data in descending order by count. Already we have the logic to get the word count. Let's make sure we assign this logic to another variable. So in this case, I'll pick this one. Then I'll say word count equal to, paste it. Let's run this. Now word count is RDD, which contain tuples like this, where each element contain the word with corresponding count. Now using this, I would like to sort the data. Let me paste the word count here, then say sort. You can see there's something called as sortByKey. You should be able to choose this. When it comes to help, you can not only use the help function, you can also use question mark like this at the end. This is a shortcut to use help function. Let's review the documentation. You see the outcome is similar to whatever we see using help function. Now let's scroll down. When it comes to sortByKey, it takes multiple arguments. Before reviewing the examples, we can scroll up and go to the details with respect to the arguments. You have first argument, it can be either true or false. True means ascending, false means descending. By default, ascending is true. Then we have num partitions. you don't need to worry too much about num partitions at this juncture. Then we have key function where you can pass a lambda function based on which the criteria can be defined. When I say criteria, I'm talking about sorting criteria. That being said, you can see the examples here. You can specify true or false when it comes to the first argument. When it comes to key func, you can pass the lambda function like this. In this case, first go to the details about sorting the data in ascending order by words. The way you can achieve is like this. You can say word underscore count, then sort by key. Then I would like to sort the data in ascending order by word. As word is the first element in tuple, we just have to run this. It will work as per the expectations. Let me actually say take of 10. Let's run this. You should be able to see the outcome. The data will be sorted in ascending order by word. You can see here. We have quite a few special characters to begin with. Those pop up at the beginning. Let me actually use collect rather than take so that we can see the complete results. That way we should be able to validate whether data is sorted in ascending order by word or not. Because word is the first element in these tuples, this will work without any issues. You can see here. Towards the end, you have Y's, then W's, then V's. Here I am going in reverse order. It means data is actually sorted in ascending order by word. Now let's also talk about sorting data in descending order by word count. When it comes to sort by key, it is called as sort by key because it will attempt to sort the data based on key. When it comes to the word count, the word is key. Hence, using sort by key on top of it, we should be able to sort the data either in descending order or ascending order by word. In this case, we have sorted it in ascending order by word. Now, if you want to sort the data based on word count, we have to swap the key and value or first element and second element. In this case, the RDD on which we wanted to perform the word count should have word count as the key or first element in each of the tuples. Then we need to have word. Let's go to the details. You will understand what I'm talking about here. Let me start with the word count. To swap the elements in the tuples, we can use map function. So let me say map, then lambda, then I for item. Then I'm switching the places for the words and word counts. The first one will be second element in the tuple. Then second one will be first element in the tuple. Now I should be able to use sort by key on top of it. Let me say sort by key. Then I have to say false. It will automatically pick the word count as the key to sort the data in descending order. If you wanted to customize a little bit on top of it, you can use the lambda functions. In this case, lambda functions are not required. Hence, we can proceed and run this. Now, let me say collect here so that we can preview all the data. Let's see what is the most popular word. It will be coming on top. You can scroll all the way up. You have empty string which is repeated 32 times. It could be because we have used lines rather than filtered lines where we have discarded empty lines. That's why it is popping up. However, the most popular word is nothing but the. It is repeated 22 times. Then to, which is repeated 16 times. Then spark, which is repeated 13 times, so on and so forth. This is how you should be able to sort the data in descending order by word count. Here we have swapped the words and counts in tuples so that we can use word count as key. Then we have applied sort by key. In case if you want your final outcome in original order where you wanted to see the words first followed by counts, after using sort by key, you can improvise like this. Let me copy this. Let me paste here. After sort by key, before collect, you can use map. Then again, you can have the logic like this. Lambda I, then I of 1, which is nothing but word this time, followed by I of 0. Let's make sure to end this with dot, followed by space, and then followed by backward slash, so that the syntax is correct. Now let's run this. We should be able to see the outcome as per the expectations. Let's sort all the way till the beginning. to preview the first few records. You can see it started with the empty string, then then to, then Spark, where we have achieved whatever we are looking for. This is how you should be able to use sortByKey either to sort the data in ascending order by words, or either in ascending order or descending order by word count. As we have explored sortByKey as well, now it is time for us to get into details about how to write this processed data into the files. Then we will consolidate and recap. Then we will go to the final solution. Then we will conclude. As we have gone through how to sort the data in RDDs, now it is time for us to understand how to save processed data in RDDs to files. Let's assign this to some other variable. The variable name is nothing but word count sorted, or wc underscore sorted. Let me paste the logic here. Let me run this. Now we have the data in the desired order. Let's explore the functions which start with save. Let me say save. You can see there are quite a few save functions. They are nothing but save as text file, save as sequence file, save as pickle file, so on and so forth. For now, we'll go through save as text file. Let me select save as text file. Let me add question mark at the end and then run this so that we can get the help of this function. Now, if you scroll up, it says it saves the RDD as a text file using string representations of elements. Now, with respect to wc underscore sorted, the data is like this. Let me say collect and then run this. You can see the data. This is the first element. Let me scroll all the way up. This is the first element, hence it will actually save in the file like this if you directly use save as text file on this wc underscore sorted. In this case, I am using multi-line string just to demonstrate. This is how the data will be written in the file. You will not be having the triple quotes. The first line in the file will be this one. The second line will be this one. Then third line will be 2,16. Then fourth one will be Spark 13, so and so forth. That being said, we don't want to write the data in text files like this. We might want to use CSV files. If we want to write the data in CSV files, then it should be written like this. So we should not be having brackets. We have to ensure there are no brackets written into the file. And also after comma, we might not prefer to have space. This is the CSV representation of each of the records. We need to ensure data is transformed in this manner before writing into the file. Then we have to use save as text file to write the data into the file. Once data is ready like this, then we should be able to specify the path to which we want to write. Let me scroll down here with respect to the help. You can see the syntax here. You just have to say path and then probably codec. Codec is not important for text files unless you want to compress the files. In this case, I don't want to get into compression. Hence, I'll be only specifying the path. That being said, now let me scroll down or let me scroll up here. In this case, instead of having the data in the form of tuples, I want to have the data like this. Here, I'm using Python's string formatting feature. First, I'm actually accessing the second elements in the tuples, which are nothing but the actual words. Then comma. After curly braces, we need to specify the comma. Then again, we have to specify curly braces. Then we have to specify the first element in the tuples, which are nothing but counts. Let me show you with an example. Our RDD have the data something like this. T equal to then 32 comma the is repeated 32 times. After sorting the data, this is how data is represented. I think 32 is the count for empty strings. The is actually repeated 22 times. Now we wanted to flip them, right? If you wanted to flip them, we can use this approach. Again, we can enclose in tuple, then say t of 1 comma t of 0. This is the logic which we have earlier. this will flip the elements in the tuples or swap the elements in the tuples. However, instead of just swapping, I wanted to concatenate these so that they are formed as CSV based strings, which means the actual values should be separated by comma. For that purpose, we have come up with logic like this: f, then in single quotes or double quotes, you specify curly braces, comma, curly braces. In the first curly braces, we can say t of 1, which means we are placing the second element first. Then t of 0, which means we are placing the second element second. Between we have the comma. Now, if I run this, you should be able to see the outcome. This is the logic which we have here. Now, WC underscore sorted will have the data sorted in descending order by count. However, when it comes to the actual strings, there will be comma separated strings, not tuples anymore. Let's run this. As it is successfully run, before using save as text file, let's say WC underscore sorted, then collect, then run it and preview the output. You can see the data is as per the expectations. They are not in the form of tuples anymore. They are actually in the form of strings. Now we should be able to use this to write to file. For that purpose, you just have to say WC underscore sorted, then save as text file, then specify the path. You can specify the path like this. You can say dbfs, then data, then word count. Even if this path doesn't exist, it will create the path and it will take care of writing the files into that location. Now let me run this. You see it have ran successfully. To validate whether data is written to this location or not, you can copy this. Then you can say output underscore df equal to sc.text file. Then specify the path, run this. Then you should be able to preview by saying output underscore df dot takeoff 10, just to make sure whether data is written to the file as per the expectations or not. Here we have not only covered about how to write data into the files, but also how to validate whether data is written as per the expectations or not. By default, when you attempt to run this again, it will fail. You might have to delete this path and run it again if you wanted to validate multiple times. You can use %fs rm command to delete a folder, and then you should be able to run this piece of code once again, so that the data which is processed already is written into the file as per the expectations. As we have gone through how to save the processed data into the files, now it is time for us to consolidate everything. We'll recap and we'll come up with the final version of word count code, and then we'll actually get into the details about how to validate whether the job is running properly or not. We'll also go through additional important concepts such as DAG, lazy evaluation, and all those things. Hence, don't give up. After this, stay tuned and go through the remaining topics as well. That way, you will not only understand how to build logic to the problems like word count, but also you will be able to understand all the key concepts related to Spark. So far in this video, we have gone through quite a few important details with respect to Spark. We have seen how to read data from files into RDD. Also, we have gone through functions or APIs such as filter, map, FlatMap, as well as reduceByKey, sortBy. These are the transformations which actually process the data. With respect to filter, map, and FlatMap, they are narrow transformations. When it comes to functions like reduceByKey, sortBy, they are wide transformations. Even we have gone through the concepts about these. We have even seen what shuffling means. On top of these, we have even gone through actions. When it comes to actions, the examples are nothing but first, then take, then collect. Even count is an action. On top of this, even save as a text file, which we have used in the previous step, is an action which actually takes care of writing the processed data into files using the format which we have come up with while generating the final output. On top of these functions, we have even touch-based quite a few important concepts. Already I have mentioned about them. They are nothing but narrow transformations, wide transformations, shuffling, etc. Still, there are few concepts which are supposed to be covered, such as lazy evaluation, DAGs. We'll take care of those very soon. But first, let's make sure we consolidate the complete logic with respect to word count. Then we'll run. We'll also go through the details related to Spark UI along with concepts such as DAX and lazy evaluation. That being said, to consolidate, first I'll start with cleaning up the location which we have used earlier, which is nothing but data word count. Then I'll go to the complete logic once again. Then we will validate. Then we'll get into Spark UI and other key concepts. Now let me create a new notebook. I should be able to say file and then say new notebook. I'll be naming it as word count PySpark final. Still the notebook is being created. Now it is created. Let me name it as word count PySpark final. Let's make sure it is attached to active cluster. You can see it is attached to active cluster. First, let me say %fs, then rm-r, dbfs, data, then word count. First, let me use ls command to list the location, then we'll take it forward. Let me say ls, then dbfs, then :/data. You can see the result here. You have word count. Let me say word count here. Let me specify rm-r. Then let me also use -f. I don't think I need to use -f. I should be able to use this command to recursively delete the folder word count. Now you should be able to see the outcome. It is saying boolean equal to true, which means it is deleted. You can validate by again saying %fs ls, then dbfs :/data. This time it will only show one folder. In my case, you might not see anything. That being said, let me delete this. I don't want to have these lingering around because these are primarily to validate. The first step is to read the data which is already there in dbfs. Again, the location is nothing but this one, dbfs, then DataBricks -datasets. You can see the datasets here. The one which we are interested in is nothing but this one. We should be able to copy this and then we should be able to take it forward. In this case, first let me say lines equal to, then sc.text file. This is the function which will actually take care of reading the data from files into RDD. RDD name is nothing but lines. Let me specify the path. Let me run this. You can see it have ran successfully. Now I'll define another variable by name words. I will have some intermediate results here. Then we'll actually sort and then take it forward. First, I would like to filter out all those lines where they are empty. For that purpose, I should be able to say lines dot, then filter, then lambda, then line not equal to empty. This will take care of filtering out all the empty lines. After that, I wanted to make sure data is flattened into words. For that purpose, I should be using FlatMap. As part of FlatMap, I'll be having this logic. Lambda, then line. In this case, it should be line dot split with space. This will actually result in RDD, which will have words from the file. First, we have generated lines, which is of type RDD. If we have 90 lines in file, we'll have 90 elements in lines RDD. If you have 20 empty lines, after this, the new RDD, whichever is generated internally, will have 70 elements. Then, on average, if each line have 10 words, after filtering and after applying FlatMap, we'll end up with 700 elements in this RDD called as words. Each element is of type string. We need to convert into tuples so that we can perform the word count. So here I should be able to say word tuples, but before doing that, let me run this. Now let me say word underscore tuples. I should be able to say words dot map, then lambda word, then word comma 1, so that we get the tuples. However, we wanted to get the word count, so instead of defining one more variable, I'll just rename this as word count. Then I'll actually use reduceByKey here. Let me say reduceByKey. Here we need to add all the second values based on the key, which are nothing but ones. For that purpose, we should be able to use add from operator. We need to ensure add is imported. The way typically we import is we import at the beginning. Let me say from operator, then import add. We need to make sure this is run. Once it is run, then we should be able to run this without any issues. However, after performing the word count, we want to sort the data in descending order by count. For that purpose, we have to sort the data based on counts. But the outcome of reduceByKey will have words as keys. We will not be able to perform sorting based on counts. We have to swap the elements in the tuples that are generated after reduceByKey. For that purpose, we have to use map function once again. Let me say map, then let me say lambda word, then word, or let me actually say I here, then let me say I of 1 as first element, which is nothing but word count, then I of 0. So here I have to say I of 0. After this, we should be able to sort the data in descending order by using this logic. Let me say sortByKey. Here we have to sort the data in descending order, hence we have to use false. The key is word count, hence we don't need to specify key func to actually pass the logic based on which data is supposed to be sorted. After this, again we want to use map function to swap the word count and word themselves so that data is properly stored in the file. Keep in mind, we wanted to save the data into the file in the comma separated format. Hence, we need to make sure data is actually formatted in appropriate format. For that, again, we can use map function. Let me say lambda I. Then we have to use string formatting. In this, we can say I of 1, which is nothing but word itself. I haven't used the appropriate square brackets. Let me use right square brackets. After I of 1, we wanted to specify I of 0. Hence, we should be able to specify it like this. We have to use these variables in curly braces. Again, I haven't specified the square brackets properly. Let me fix it. Now we have the required logic to get the word count. Let's run this. You can see it have ran successfully. Before attempting to write into the file, let me preview the data so that the data is as per the expectations. Here I am saying word count dot collect so that I can preview the complete data. You can see the outcome here. Let me scroll up. You can see the details here. However, I would like to convert the strings to uppercase so that I consider case insensitivity when it comes to performing the word count, which means Spark in uppercase or Spark in lowercase or Spark in mixed case is considered as one word. For that purpose, I should be able to apply the logic to convert the string to uppercase here. After FlatMap, here I can say word.upper. Let me make sure I take care of this. Now let me actually run this once again, and then run this once again, then run this to preview the outcome. This time it is as per the expectations. Let's scroll down and see the details. You can see the details as per the expectations. So now we should be able to write this to file. To write this to file, we just have to say save as text file here. Then we have to specify the path. Already the path is deleted, hence we should be able to specify without any issues. It is nothing but dbfs:/data word count. Now let's run this. You can see it have stored the data in the target location. In case if you wanted to validate, you can validate using the same steps which I have demonstrated in previous step. This is how you can come up with consolidated logic in a notebook so that it can be deployed as a job. Make sure you understand the overall process to come up with logic based on the requirements. Word count is a perfect example to get started. However, when it comes to the actual projects, you need to ensure that you understand the requirements before getting into the implementation. I'll also give a pro tip where you can think about performance while coming up with the logic itself. But for now, make sure you understand the overall process to come up with the logic to read the data, then process, then write it to target location. That being said, now let's make sure we run this end to end, and also we'll actually go to the details about how to monitor this using Spark UI. Whether it is running or whether it is done, we should be able to review the job details using Spark UI. We'll be spending quite a lot of time on Spark UI. Also, we'll cover other important aspects such as lazy evaluation and DAG, because it is important for you to understand the difference between transformations and actions. Yeah, we have come up with the final code with respect to word count. Now let's understand how to monitor this using DataBricks as well as Spark UI. You have to review something called as driver logs and also Spark UI to understand what is going on when we run this job. First of all, you need to make sure the notebook is attached to the cluster and also it is run. I have already ran this notebook. Also, I have added this cell at the beginning so that the target location is deleted, and then at the end it is written without any challenges. Apart from this cell, I haven't made any changes. The notebook is successfully run. Now we should be able to go to compute, then go to active cluster. In case if you wanted to review driver logs, then you have to go here. You see there is something called as driver logs. It will get you the consolidated information about what is going on with respect to the job. If there are any issues, if the exceptions are handled properly, or if Spark itself have raised any exceptions, all those exceptions can be reviewed under these. This will facilitate you to troubleshoot where the issue is with respect to your Spark job or application. In case if you wanted to deep dive about what is going on about your application, you have to go to Spark UI. Once you go to Spark UI, you should be able to review all the details. In case if you wanted to open this in a separate tab, you can click on this. It will open in a separate tab. Using this also, you should be able to review Spark UI. Let's get into a little bit details with respect to driver logs. Then we'll come back to Spark UI. When it comes to driver logs, you have standard output. You can see standard output here. On top of it, you also have standard error and log4j output. You don't need to worry too much about log4j in many cases. As of now, there are few exceptions with respect to log4j. Don't worry too much about it. The one which you should be focusing on is nothing but standard error. If the exceptions are raised or if system raises any exceptions, you will see those exceptions here. Other than any exceptions or errors, typically they'll be logged as info. All the info related logs can be seen under standard output. You can review these, and if you see any anomalies or abnormalities, then you can troubleshoot further and see where the issue is. Once the root cause is identified, we should be able to fix the issues by making required changes to the code. However, you need to keep in mind you have to raise the exceptions appropriately if you end up writing code for your Spark applications. Based on how you handle the exceptions, you will end up seeing the errors and exceptions either in standard error or standard out. This is all about driver logs. Now let's get into Spark UI. You can click on this to go to the main page of Spark UI. You can see here the same thing. It is shown in full screen. In this, you have jobs, stages, storage, environment, executors, SQL/DataFrames, and so forth. We have developed a word count application using RDD based approach. You might not find anything in SQL or DataFrame because we haven't used DataFrame APIs or SQL queries. You should be able to see most of the details with respect to the application which we have developed under jobs. You can see here. Now, with respect to this word count job or word count application, it is submitted as 3 jobs. You can see the job IDs here, 0, 1, and 2. These 3 jobs constitute the execution of our Spark application, which is nothing but word count. If you want to get into any specific job details, you can click on this link and then go to specific job details. You see there are stages within jobs. I'll not be getting into all the details for now. I just wanted to show how Spark UI look like and how it can come handy with respect to exploring the details about the Spark applications. Also, I have already covered with respect to driver logs, which can be very handy when it comes to troubleshooting the issues. In this, one of the important aspect is nothing but DAG visualization. What is DAG? I'll be covering very soon. This will give you an idea about how your job is going to run. With respect to other aspects about what are Spark applications means or jobs means or stages means and all, I'll be covering those details in a separate video. The link will be provided in the description. You can click on that link and take it forward. For now, DAG visualization is one of the important aspects. You should be able to visualize DAG with respect to specific job within the application like this. Now let's go back to the jobs. Already we have reviewed the DAG with respect to first job, which is nothing but this one. Now let's click on this. Here also we should be able to visualize the DAG by expanding this. The DAG is more or less the same. However, if you observe, this is grayed out. Let's go back to jobs once again. Now let's review the third one. The third one is nothing but this one. Also, you can see the code which is being used to generate these jobs. With respect to the first job, which is nothing but this one, and the second job, the code is the same. However, with respect to the third job, it is talking about save as text file. You can see here. You can click on this and then go to the job page. You can see the DAG here. It is the complete DAG, which not only talks about reading the data from the file, then applying filter, map, etc., then applying reduceByKey, followed by sortBy, and then finally save as the text file. This is the complete DAG representation of our word count application. In case if you wanted to go into further details with respect to a particular stage within a job, you can click on the link here, and then it will give you further details. Let's wait until this is fully loaded, then we'll take it forward. Now you see, it have given the details with respect to the stage on which we have clicked. When it comes to Spark applications, there is a hierarchy. At a higher level, you have application. The application will run in the form of multiple jobs. Each job will have stages. Between the stages, shuffling happens. I'll not be getting into too many details with respect to applications, jobs, stages, and also other details related to Spark architecture. We'll be covering those details in a separate full video. That being said, another important section which I want you to review is nothing but executors. You can click on executors here. It will talk about how many executors are used to run our application. You can see there is only one executor. It is because we are using DataBricks Community Edition, which will give us only one executor. That executor is both driver as well as worker. When it comes to multi-node clusters, you will have one driver and many workers. We will understand those aspects when we actually start using multi-node cluster at a later point in time. That being said, these are the important aspects with respect to monitoring our jobs using both driver logs as well as Spark UI, which are made available to us via the cluster. You can also review these details using the notebook. Now we are back to the notebook where we have our word count application. Towards the end, if you observe, you can see the Spark jobs. In the other cells, there are no Spark jobs. It is because of the lazy evaluation. We'll be talking about both lazy evaluation as well as DAG very soon. For now, just keep in mind, not all Spark APIs will invoke Spark jobs. Only actions and a few transformations will invoke Spark jobs. That being said, here also you can go to a particular job. In this case, this is nothing but job 0. You can click on view to go to details with respect to particular job, and you can see details with respect to particular job here. This is same as what we have seen earlier. If you go to complete Spark UI, you can click on this to go to complete Spark UI. Let's wait until it is loaded. You can see it have taken us to job 0. If you want to go to all jobs, you can actually click on jobs, and then you can see here, and then you can navigate to whatever job you want to navigate to. This is a brief overview about both driver logs as well as Spark UI. You can always go to the cluster and then go to driver logs and then click on these links to download. In case if I have to download standard error to troubleshoot the issues, I should be able to click on this. It will automatically download for us. We should be able to expand and then open this using our favorite editor and then go to the logs to troubleshoot the issues. As of now, it is only 913 bytes, but if we run huge jobs or if we run jobs consistently in the cluster, the log files can be huge. That's where downloading this and then searching through it will help. As we got an overview about driver logs and Spark UI, the next step is to go through details related to lazy evaluation and DAG. In that process, we'll also revise all the key concepts that are covered in this module related to Spark RDDs. We are almost at the end with respect to Spark RDDs and APIs on top of RDDs. Before getting into the final topic, which is nothing but DAG and lazy evaluation, let's recap what we have covered so far. Then we'll get into DAG and lazy evaluation. We have understood how to start with DataBricks environment to learn Spark. Also, we have reviewed the datasets. Once we reviewed the datasets, then we have spoken about the three data structures Spark support. They are nothing but RDDs, datasets, and DataFrames. If it is Python, we typically use DataFrames. If it is Java or Scala, we have the flexibility to switch between DataFrames and datasets. On top of this, we have even covered details about the variables or objects that are available out of the box when we use the DataBricks environment. They are nothing but Spark as well as SC. SC is of type Spark context, whereas Spark is of type Spark session. We have not only covered these, we have even covered quite a few important transformations and actions. The transformations which we have spoken about are nothing but filter, map, group by key, reduce by key, sort by key, also reduce. When it comes to actions, we have gone through details with respect to count, collect, first, take, and save as text file. Using all these, we have not only reviewed the data, but also we took care of developing word count application. Now, it is time for us to get into DAG and lazy evaluation. First, let's recap the difference between actions and transformations. When it comes to actions, they are primarily used either to preview the data or to write the processed data to specific target location in a specific file format. When it comes to transformations, they are primarily used to transform the data from one form to another. If you wanted to filter, you use filter. If you wanted to apply row level transformations, we use map. If you wanted to perform aggregations, either we use reduce or reduce by key. These are all nothing but transformations. Transformations are actually used to transform the data. Once again, I am reiterating, actions are used either to preview the data or save to some target location. Transformations are actually used to apply required transformations on top of the data. Another important difference between actions and transformations is that when it comes to actions, they trigger the execution. When it comes to transformations, most of the transformations doesn't trigger execution. You have to perform action to trigger the execution. When it comes to actual implementation, we read the data from the file, then we apply transformations to process the data, then finally we perform the action either to preview the data or to write data to target location. Only when action is performed, the overall logic of reading the data from the file, then applying the transformations and then writing the data to the target location will be executed. This is called as lazy evaluation. Lazy means being lazy, which means postponing the execution to a later point in time. Evaluation means execution. So the process of postponing the execution until either an action is performed or specific transformations which trigger execution is performed is called as lazy evaluation. Now I am in the word count final. If you observe here, I am actually reading the data from the file into RDD. The RDD name is nothing but lines. Then filter and FlatMap are applied to convert the lines into words. Then reduceByKey is used to get word count to make sure data is sorted in descending order before saving into the file. Here we have used sortByKey. With respect to this one where we attempt to reading the data into RDD, and this one where we attempt to convert lines to words, there are no Spark jobs. It is not displaying any Spark jobs even though these two cells are run. But with respect to this one, there are two Spark jobs. This is where it have read the data and also it have performed converting the lines to words and also the word count. Even data is sorted. Then finally, another Spark job related to saving the data into the file. These two have Spark jobs, but these doesn't have, which means until this point in time, it haven't processed the data. No matter how big data size is, these two will be returned immediately. However, this will take time based on the volume of data that is being processed. Here, because of the sortByKey, it have triggered the execution. Then here, because of save as text file, it have triggered the execution until either the transformations like sortByKey or any action is performed, the execution will not be triggered. This process of postponing is nothing but lazy evaluation. To support lazy evaluation, it has to build something. That something is nothing but a DAG. Until actions are performed on top of RDDs or even DataFrames, the DAG will be updated only based on the actions performed. Based on the structure of the DAG, the logic will be executed. Now let us understand the term DAG. When it comes to full form of the DAG, it is nothing but directed acyclic graph. It is a common term in computing. When it comes to the definition is nothing but DAG is a finite graph that consists of vertices and edges where the edges have a direction and there are no cycles, which means once a particular edge is touched, it will not come back to that edge once again. That's why it is called as acyclic. The key characteristics of a DAG are nothing but directed and acyclic. DAGs are not only limited to Spark, they are used in many other areas. Even in Airflow, with respect to orchestration, we use DAGs. Even in blockchain technology, the DAGs are used. Hence, DAGs are not limited to Spark. They are used in other technologies as well. In Spark, DAGs are fundamental to how it processes data. Spark converts each job into a series of stages that are broken down into tasks, all represented in a DAG. The Spark engine then optimizes the execution plan based on this DAG, which can help reduce the amount of data shuffled across the cluster and improve job performance. With these simpler ones, you will not be able to understand how the optimization takes place. Keep in mind, when it comes to one point to another point in a DAG, there might be multiple routes. Spark will determine the best possible route, and using that best possible route, it will take care of the execution. When it comes to DAGs, they are versatile and powerful structures widely used in computing for organizing tasks, processing data, and modeling relationships, making them a critical concept of both theoretical computer science and practical applications. Here, you don't need to break your head if you don't understand. As long as you keep in mind that DAGs and lazy evaluation are related, you are good. So when we come up with the APIs on top of Spark, instead of executing immediately, it will wait until a particular action or transformation is performed. This process is called as lazy evaluation. To support lazy evaluation, Spark uses DAGs internally. You have to just keep these things in mind. As we have gone through quite a few important Spark basics, including RDDs as well as the APIs on top of RDDs to process the data, now let's understand next steps. Next, you should be familiar about DataFrame APIs, also Spark SQL. Also, you should be familiar about how to build different types of pipelines, be it batch pipelines, streaming pipelines, ML pipelines, or even LLM-based pipelines. On top of these, you should also be familiar about DataBricks as a platform. Keep in mind, DataBricks is the company who invented Spark. They contribute to open source Spark more than any other company in the world. On top of these, you should also be familiar about advanced file formats such as Delta, Iceberg, etc. These actually facilitate you to perform ACID operations using Spark. Whatever I have referred are on top of Python and SQL. Without having decent knowledge about Python and SQL, you cannot be a proficient data engineer or fully equipped data engineer. That being said, make sure you go through remaining topics as well so that you gain required skills to be a data engineer. In case If you want to learn more about Spark or DataBricks, look at the description. We have quite a few full videos related to DataFrame APIs, DataBricks platform, Spark SQL, etc. You can click on those links and learn those additional stuff as well for free. However, there might be additional content which we might publish in future. If you want to get notified whenever we publish the content, you just have to subscribe to our channel and click on bell icon so that you are notified whenever the content is uploaded in our channel. At ITversity, we also offer guided programs. In case if you want to learn Spark under our guidance, including support as well as job placement assistance, feel free to reach out to support@itversity.com. If you enroll for our premium courses, you will not only get content like this, you will also get support whenever you stuck somewhere. We will also provide job placement assistance where we'll be helping you to build resume, conduct mock interviews, even will help you in building your LinkedIn profile. Also, we will refer you in our network. We have a deep network and we'll be able to refer you in case we feel you are the right candidate for a given company. So these are some of the aspects with respect to job placement assistance. In case if you wanted to learn from experts and also take our support from the perspective of job placement, don't forget to enroll to our guided programs. If you are interested, just send an email to support@itversity.com. We'll take it forward. That's it for now with respect to this video. Let's catch up in the next video.